So welcome everybody. We are honored to have Professor Bilal Khan speak to us today. The talk is entitled ODIN, a new platform for contextual collection of social behavioral data from cohorts over long time scales. Now this is really, it's a talk, but it's really an invitation to collaborate with him. And the first time I met Professor Khan, I was able to see his CV. It's like no other, it's a work of art. This is brilliant. And it's like no other CV anyone has ever seen. The first page is a massive diagram with arrows and areas of interest and expertise. It's phenomenal. It should be in a museum somewhere. But currently, Professor Khan is the co-director of the Longitudinal Networks Core at our sister COBRE at the University of Nebraska-Lincoln, UNL COBRE, where he's the Happold Professor of Sociology and Computer Science. He is about to transition to Lehigh University, where he's going to co-direct the Health Data Warehouse. But I would encourage everyone on this call to listen to him carefully and think about ways to collaborate with him or pick his brain. He's brilliant and he's a very personable, great guy, and we're honored to have him. So take it away, Bilal.
Thank you so much for that generous introduction, Jody. And thank you everyone for coming to attend this talk. I'll be presenting a new platform that I've been developing. It's been a long journey. The first funding for it was actually 2009 from NSF, and it's been under continuous revision and adaptation since that time. So the motivation for this platform is that we frequently want to collect data over time from cohorts. The classical way to do this is to subject the cohorts to interviews as a series of panel waves, and we can't collect data at very fine temporal resolution because that produces too much of a burden both for the field staff and for the subjects. But if we do it too infrequently, then we get very low resolution data, and we also lose a lot of people in between successive waves. So we're trying to maximize the resolution of the self-reported data. We're trying to minimize the participant burden, and these two things are essentially in conflict. There's a clear trade-off there, and the only approach to sort of getting blood from a stone is to only ask a question when you have some confidence that asking it will produce a valuable piece of information, which again seems like how are you going, if you already know the answer and the fact that it's going to be valuable, why, there's something self-referential and contradictory there. But the idea here is perhaps if we could ask questions in a context-sensitive way, and we know a priori that in certain contexts the answers are likely to be of value, then we can trade off, find an optimal trade-off where we're making use of the limited attention span of the participants and getting the most valuable data out of that process. So that's the general arc of the motivation. Now, what exactly do we mean by context? If we're going to ask our participants questions based on the context in which they find themselves, well, we could mean the distal context, what they've told us about their distant past, their childhoods, their upbringings, their family histories. We could mean their proximal context, by which I mean what happened to them very recently in the last 5 minutes, in the last 5 hours, in the last 5 days. We could mean their spatial context, where they are right now, whether they're at the gym, whether they're at their home, whether they're on the street, that we could mean that. How are we going to collect information about their context so that we can decide that we ought to ask them a question right now because it's likely that the answer that they give will be valuable to our investigation? Well, turns out we already have this technology and we carry it around all the time, and it's being used by people for purposes less noble than science. And that is the cell phone and its sensors, right? So the cell phone that you carry has a GPS sensor, which is continuously able to evaluate your location. Your Bluetooth sensor is able to detect other Bluetooth devices that are nearby. So if you assume that everyone is carrying a cell phone and all your participants are carrying cell phones, then in fact, they can detect co-location with one another. You could place beacons at locations of interest, and so you could know when individuals in your study were co-located with your locations of interest. There's accelerometers on your phone, which are used to implement things like step counters and so on. So you know something about their physical activity, you know if they're driving, you know if they're walking, you know if the phone has just been sitting there on the couch. And then you have the ability to link up with a lot of different kinds of sensors, like the Fitbits, the Empatica E4s, and from this you can get a fair amount of physiological data in near real time. And then things that you might not think of as sensors, but in effect they are. You have access to time and the calendar date. You have access to historical answers to previous questions that you might have asked this person. That's a kind of sensory signal coming from the phone. And you have user-initiated actions. You might have buttons that they're pressing on the phone to indicate that certain things are going on. That's a kind of sensor. So the collection of all of this you can think of forming the context. And on the basis of this context, then you want to ask questions. So this is the information architecture of the ODIN system. And I'm going to read it through in order here, but you should have the sense that all of this is happening all the time. So the researcher creates a set of questions and associates to each of those questions logical rules which specify when the question should be asked. That goes via a web interface to a server. Now, the second step, a participant has an app, and that app gets automatically customized to contain within it the questions and rules that the researcher specified. Now, in step 3, this app is continuously monitoring the participants' sensor data feeds. And then when the rules specified by the researchers are evaluated true, then the participant is prompted with the appropriate question. The participant answers that question or perhaps ignores that question, but regardless, the action of the participant is stored on a secure server, either as missing data or skipped questions or actual answers to questions. And then the researcher can log into that website and look at the data of their participants in their study and potentially interact with them and change things and adapt accordingly. That's the loop of control. So this is just what the website looks like when you're designing questions and rules. You log in, you specify questions. This is for an alcohol study. It can be a multiple choice question. You specify what are the choices. This column over here are the questions. How much alcohol, wine, beer, hard liquor did you have yesterday? And then these are your choices. And over here, associated with each of these questions, you can specify one or more rules. Here, there's only one rule, and this rule says you should ask this question every day at 10 o'clock. Now, the logical structure of these rules can be fairly complicated, and it refers to those sensors that are being engaged. Here's a second multiple choice question that asks, select all the reasons why you chose to drink yesterday. And then the rule for this is that you should ask this question if the person answered either choice 2, 3, or 4 to the previous question. So this is a kind of the context in which the second question should be asked is that the participant should have answered the first question in a particular way. So once you've written up all your questions and rules, the next step is you generate a set of coupons. These are essentially random IDs. and you list them out here on the website. You say, I'd like to make 10 coupons, and then you're ready to go out and recruit your participants with this list of coupons in hand. So in step 3 is your actual recruitment process, which in our case, we've been dealing principally with hidden, hard to reach populations. So there's a whole, science of finding your participants and screening them, which this app can't really do help with. But let's assume you get your participants and now you're ready to enroll them. So you ask them to download this app, which is available for Android or iOS, and you assign them a coupon. They type in this coupon into the app, they press the register button, the app connects to the server, gets fully customized based on the questions and rules that were specified. And now, as this individual carries the phone around, they're going to get asked questions when the local sensors on their phone detect that the time is right. So as this study is going on, then the researcher can log in and they can see the answers that are coming in and the data that is coming in from their participants. And for each row here, they'll see which coupon is providing the answer, why on earth did we ask them that question, what time did we ask them that question, what time did they answer that question, and what did they answer? And then there's a bunch of other fields like that. So you can examine the data, download the data, analyze the data, and potentially you can make modifications to the study protocol. Although generally we don't have the analytic machinery to deal with that kind of continuous changing. But in principle, it's possible. Then at the very end of the study or during the study, the participant can look in the phone and they can see, okay, what is my performance here? I've answered 8 questions out of 10, so I'm getting an 80%. I'm on target to make a certain amount of money in this study. And from that, they can have a sense of how they're doing and what to expect when they come to get their incentive payment at the end. I'm going to give you a very, very fast demonstration of the system here now. If I just let me see. Maybe that's Gail was saying, if we don't have a technical glitch, it's not exactly. So I hope you see my entire screen.
Yes, I can see it.
Okay, great, super, thank you. So this is what the website looks like. And sorry, one second. I'm using my personal phone for a demo. It's not a good idea. So I'm going to log into the website. This is what it looks like. This is the live website. And I can now make a new study. I give the study a name. This is the live demo study. It's going to last 10 days for participants. And then it's now been created. I can go and edit it. When I edit it, I can specify what sensors am I going to use. For example, you can choose any of these sensors that you want to use in your study. Let's add the GPS location. And then it asks you how frequently do you want to be measuring the GPS location, let's say every 5 minutes. So now you've specified that you want the GPS sensor to be used in your study. Then you can set up your consent forms. If you plan to get consent on the phone itself, you can specify each of these different fields in the consent form. I'm just going to say this is in the demo, so you know that I'm not cheating. And then you can specify contact information for your participants, who to call if they have a problem, if they have a technology problem. And then you set up your actual survey. Over here, this is where you start to add your questions. So you specify a tag, like here I'm going to ask, this is the tag for the question. This is the actual text of the question. And then you have a choice of question types. For now, we'll just keep it multiple choice, but you can also have free text. That you can randomize your choices and specify how many answers they're supposed to check off. Then you, at this point, you have your question, and you can add since it's a multiple choice question, you can add responses that are valid responses. So here you can say, I feel optimistic. And perhaps neutral and pessimistic. So there's my question, and then I can add a rule associated with this question. These are the rules that specify when this question should be asked. Because we said that we want a GPS sensor in this, we're allowed to associate these types of rules with this question. When a person is at a location, when a person is not at a location, but also these types of rules can be, are always valid. Rules that are based on time, rules that are based on pressing a button, and so on. So let's just make this based on time. Each rule can either live on the phone or it can live in the server. So let's make this rule live on the phone. And now you specify information about this rule. And I'm just going to make this rule happen every minute, let's say, so that you actually see it fire. That specifies when this question will be asked. And then you also have to say, how long will this question be shown for, and which users is this going to be shown to? In other words, you can sort of partition your cohort into different groups and have rules that are group specific. So for now, we will just avoid talking about that. And then you can filter things and make the rules more complicated and nuanced. We'll ignore that for now as well. So here's a question, and it has just one rule associated with it. And this is the most complicated part of it, designing this, making sure that it passes IRB, making sure it produces the data that you're interested in to test your scientific hypotheses. This is a kind of survey design that is new and different from anything that people have been doing for the last 100 years. Then after that, you're ready to go. The study is in preparing phase and you're ready to roll it out. You push it into in progress. Now it's in the in progress state. The next thing you do is you make some coupons. You say, okay, I'd like to pick 10 coupons. Oops. And they're all going to be in group 1. So now you have these 10 coupons over here. These are the random strings that you're going to hand out to participants that you deem to be eligible. And then you go and you interview someone and you say, okay, prove to me that you are a member of the population I'm interested in. For example, a rural drug user. In one of the studies we were looking at, we were interested in that particular population. And then they download the app and they install it on their phone, they run it, and then they type in this coupon number that you've given them, WBY, WC, PW, HMC. All right, this is the COBRE demo. That's the consent form that I changed so that you'd be convinced that this is a real live thing going on here. And then I'm going to press the next button, go through all of my consent forms, which I didn't change the content of, but you could. And then at the end of it, you have your final thing here. You say agree, and the participant now agrees. And there's your screen. We don't have any questions for you at the moment, but we'll notify you when we do. And in roughly 1 minute, you're going to see a question pop up here asking me how I'm feeling, optimistic or pessimistic, and hopefully I'm feeling optimistic. Okay, so going back to the demonstration while I wait for this, so going back to the slides, we've used this system in a number of pilot studies. I'll return to full screen in a second, but for now, we used it in a study of undergraduate students over 46 days. Students were carrying around this phone for 30 days roughly, and there were 15 of them. We had 3 different questions and 7 rules. It looks like this question has arrived. So the questions popped up because it's supposed to ask me that every minute, and it's asking me how I'm feeling, optimistic or pessimistic or neutral, and I'm going to answer that here, and now that's been answered. So hopefully you get a sense of the workflow of this. Let me go back to showing the full screen. Oh no. Okay. Do you see the full screen slide now? Could someone confirm?
Yes, I do. I see it.
Okay, super, thank you. Okay, so so one of our early pilots involved undergraduate students. We gave them no incentive. They were going to get credit whether they answered questions or not. And so we had particularly poor response rate. 48% of the questions that we asked were answered. Then we had a pilot study that involved homeless youth in the Lincoln area. They carried phones around for 28 days. The response rate was much better there because most of them didn't have their own phones. We were giving them phones to use, so they were very excited to use them, and they answered the questions at a much better rate, 74%. And then the Radar Center, which is got a cohort of 600 or shooting to get a cohort of 600 rural opioid users. We recruited 31 of those individuals and asked them to carry a phone around for 14 days and answer questions about drug use behaviors on those 14 days. And there we got a roughly 87% response rate. So that was really quite promising. So I'm not going to say much about this study, although I think that probably many of you might be interested in its content. But it's been published here in this 2021 article on using EMA on people who use drugs. So the next steps of this are actually to take ODIN into a just-in-time adaptive intervention application space. And so here what I've done is I'm just showing you that we have that loop of control that I mentioned earlier, but now what we're doing is we're instrumenting a client of this database in the back end, which is an artificial intelligence analytics engine, which gets the data, analyzes it, potentially consults with experts, and then pushes interventions out to the participants. So I'll give you some examples of projects which are beginning to add this loop of just-in-time interventions into what used to be sort of the classical data collection and analysis model that sits in the background of this slide. So the first of these is a recently funded R21 from NIAAA that looks at mapping out the processes of recovery and relapse in alcohol use disorder, and looking at specifically the co-evolution of craving, affect, stress, and access to alcohol. So the idea behind it is we have a cohort of 60 individuals who are in non-hospitalized residential treatment facilities, and they use the app to answer daily questions, contextually driven questions on craving, affect, their stressors, and their proximity to alcohol. and also their proximity to social support. So that longitudinal data is being collected over time. It's being pushed into a backend server. The backend server is building individualized predictive models that attempt to forecast spikes in craving or forecast spikes in access. And those spikes, the idea behind this project is that if that the predictive power of those models is sufficiently validated, then they could be the foundation of a loop of just-in-time interventions where when there's an imminent spike in craving or access, we would send a signal to facility staff at the residential treatment facility, and then they could decide to send some app-based mHealth intervention to the program participant. So this is sort of the loop of control. And the R21 is really just looking at this one arrow over here and laying the groundwork for if that is successful, then the pitch is to go for the other three arcs here. That's sort of the justification of that project. So, of course, in order to do this, we have to sense data to see where the individual participants are. And this is just a picture of that sensing happening in real time. And you can see that we sense a lot of, this is a single individual moving over the course of 15 days. And this is downtown Lincoln, Nebraska, the hotspots. And for this study, we need rules that are based on GPS location. And so we have rules that are that fire when an individual is close to a location where it is known that you can buy alcohol. And also there are rules which fire when they are close to a location and time when we know that there is an AA meeting happening at that location and at that time. So we're asking them questions right after they're having been at those types of locations. And this is an attempt to get past the problem of recall and also minimizing participant burden and getting fine-grained temporal data. There's another example. I won't say too much about it because it's a little bit far afield from the COBRE's focus, but it just gives you an idea. This is a just-in-time intervention that seeks to enhance student performance in STEM disciplines. The idea here is we have 150 students. They're all carrying around the app. They're answering questions about their social interactions, their attitudes about the class, their behaviors within the class, and that's being merged with data about their academic performance on assessments within the class. So that produces these multidimensional trajectories across the whole semester. And then we cluster these trajectories and we view clusters of trajectories as types of experiences. You can think of it as a cluster is a type of story that arises in students' lives. And so then we take those story types and we train a machine learning model to predict, based on proximal data of the student, what their story type is likely to be. And then we meet in focus groups with counselors. We talk to them about the different story types. We ask them to design intervention messages that are appropriate to each story type. In other words, we say, if a person who is going through this type of story came in to see you, what would you say? And those messages are then incorporated into an actual modified version of this ODIN app so that students can receive those messages directly within the app without ever going into the counselor. And then finally, this thing is going to be tested in an RCT with 2 cohorts in which one of the cohorts is getting the messages and the other cohort is not. So this gives you an idea of that. And of course, in order to do this kind of study, we're interested in asking questions that are triggered by social interactions between students. And so that requires sensing their proximity to one another, which we do via Bluetooth. Here's an example of that kind of data. Over here, each of these colored lines is an individual student, and the y-axis represents how many other students are within their Bluetooth neighborhood. And so you can see this initial spike when everyone's Y value is high is because that's when the lecture is happening and they're all sitting in the same lecture hall. But then later on in the course of the day, they do have interactions, and you can see this is not just a flat line. They're sort of going off and having social interactions with one another. And there are many other ongoing projects that are using ODIN. There's a project on family, on the role of early family environment in child behavioral health, which involves strapping a newborn infant, a very young infant, with a beacon, and then putting a cell phone in the pocket of the parent whenever they enter the room, whenever they enter the house, and asking the parent questions on the basis of proximity to the child. There's a number of other projects that are sort of in very early stages, as in they're in that limbo state between passing the scientific review committee and not yet being funded. But in any case, I just wanted to sort of put these projects up here and say that some of them have required us to build new types of questions. For example, Anna Jaffe is working on alcohol myopia and has wanted to do psychometric evaluations based on context. So rather than just asking multiple choice questions, the participant has to complete a kind of reaction task assessment on the phone. And that's a sort of new type of question that they have to deal with. Kim Tyler at UNL in sociology is interested in youth experiencing homelessness, and the aim is to build personalized models that forecast substance use risk and mitigate that risk through just-in-time intervention, again, messaging interventions. So just to close out, I would say most of the things that I've shown you today have fallen into this architecture where you have a population, you're collecting data using this cell phone platform. The data is being subjected to machine learning to develop individualized models. And then those individualized models are used to make forecasts based on a continuous stream of data that's coming in. And then those forecasts drive some kind of intervention delivery, which happens again via the cell phone platform. So this is sort of the loop that you've been seeing a lot of, but this project actually arose from a more classical kind of use case where we were taking data, we were doing statistical modeling of the data, and then we would have a population model from that, and that would just be your basic science, right? And then we graduated from that, and we started taking these population models and putting them into agent-based simulations and using those agent-based simulations to try different kinds of intervention strategies and evaluate different intervention strategies and make recommendations for public health policy. So those two workflows are sort of different in their time scales, and also looking at the bottom workflow looks at sort of population level effects, where the top one is really looking at individualized interventions. So that's the end of my talk. I want to thank you all again. And a lot of people have gone into making this system, and in particular, the software engineering team is here listed on the right. And I'm happy to take any questions that you might have.
Wow, that was just fascinating. I found that fascinating, and I'm thinking this was funded by the NSF. I'm thinking maybe it might have got some funding from the NSA. look at people's lives, and I'm kind of thinking, you know, there's sensors in cars, there's sensors in appliances and homes, and there's Siri and Alexa devices, and I'm wondering about tapping into all that stuff too. I don't know if that's doable, but you know, it kind of struck me several years ago, and I'm talking to some patients. You know, they kind of have a traditional 9-to-5 job, and they go mow their lawns on the weekends, and I kind of have a sense of what they do. And then other patients come in, you know, they got locked up, and then they got released, and then they're off to I don't know where doing I don't no idea, and they can't really tell me. They can kind of tell me where they stay, but they can't tell me what they're doing during the day. They don't have any idea. They're just running around trying to, you know, hanging out or partying or trying to get out of withdrawal or trying to get high or, you know, whatever they're doing. They don't have a good. I mean, they can't even tell you what they're doing. I have no idea what they're doing, and I'm kind of thinking that, you know, when I walk out in the street and I look at people going around and going to work, like, how does this whole thing work? Like, how do people get this idea? Because I have some patients that I don't know what they're doing every day. They have no idea what they're doing. They're just doing something. And other people that are, you know, their whole life is planned out and plotted. And it's just, so I'm thinking as you're describing this, you know, you can get a sense of what actually people do. And of course, the first thing that comes to my mind is thinking, oh, wow, we could predict when people are going to overdose. Like you can look at what they do during the day, where they do it, and we know where the overdose hotspots are. And in fact, you know, maybe we can retrospectively look at people, or maybe through your cohort, like where are people overdosing? Like, and what is different? And is there anything that we can pick up that would say, wow, you know, danger, flashing lights like, ooh, this is somebody about to overdose. But even more than that, you know, there's things that we want people to do. We want them to get into treatment. We want them to take their medicines. We want them to get to the methadone program or take their Suboxone. And are there even, you know, could we tap into those biological stuff and look at the, you know, look at those times when they're likely are taking their Suboxone, their buprenorphine, and see if there may be something predictor of how they missed the dose, or where they actually used something else, and you know, or they used a stimulant or something. I mean, it seems like it's such a wide open field to try and get a handle on what people's lives are, and you know, yeah, it's connected to these affects and their, you know, their decision making and their. So I don't. Maybe I'm throwing a lot out there, but
I think you know, in the alcohol relapse study, what we realized early on is that it's difficult to actually get enough instances of relapse in the cohort, right? So the strategy frequently is, well, we know what the drivers of relapse are. I mean, craving is a driver of relapse, access is a driver of relapse. You already have a theory behind it. So if you could predict spikes in the drivers, then you have a forecasting model for risk, because risk is somehow the product of these the drivers themselves, right? So that's sort of what we decided to look at was, you can certainly tell when a person is, you know, potentially has a spike in access because you're tracking their GPS location, and you know the locations where they have access. So that's one possibility. And then if you can model their craving, and the craving is being driven by stress and by affect regulation, then you could forecast increased risk. And I think that could happen. That kind of approach would be feasible in the case of drug overdose as well. Like drug overdose itself might be too difficult to capture enough data on as sort of a black swan event, but if you can model the factors that that increase the risk of overdose and forecast those factors individually, then you can take the composite of those and come up with a kind of risk score.
Yeah, unfortunately, the overdose is getting a lot lighter these days. It's
Yeah,
almost a white swan.
yeah, that's true. That's true.
So, and non-fatal overdose is obviously far more prevalent than fatal, but they're both problematic and both obviously something that we want to intervene on and prevent. Now, what about data from other sources, from the cars and appliances and whatnot?
Well, it's an open architecture in the sense that if you have a device that has an API, you can plug it in to the architecture, and we've got a list of people who want to do that. So, for example, there's the Backtrack Skin, which is blood alcohol content sensor, and there's a number of projects that want to integrate that. So we really tried to design this. Too frequently, this kind of an app has been built for a specific study and then thrown away right after. And that was the thing that I wanted to get out of. I wanted to get out of the disposable culture of data collection and really build something where you could synthesize multiple data streams without rebuilding something from scratch. So the Fitbit is on our list. It has an open API. I don't know about cars and Alexa. I haven't thought about that, but in theory, if it has an API, it can be included into the data stream.
What is an API?
The vendor has to say, if you the vendor has to provide a description of how you can programmatically access the data that they are collecting internally. So most vendors do that because they want third-party companies to come in and develop applications of their hardware because it's going to just drive their sales. Yeah. The only company that doesn't like to do that is Apple. Apple likes to lock everything down and tells you nothing about it.
Now, just another kind of naive question. Does this cost, does this eat into people's data plans, and does it cost the patients more money?
Well, so it's adjustable. If you as a researcher need the data to be updated and you need to be able to monitor it on a continuous basis, then they have to be pushing up. Then the app has to be set up to push data up frequently. But we've found that pushing up the data once an hour doesn't really doesn't affect anything. It's less than going to a web page. The data is pretty light, so we've been very careful about making it not noticeable in terms of battery usage and in terms of cell phone plans. But even in some cases, it's perfectly fine to not push the data up at all. When the subject comes back at the end of the entire 30-day period, you just upload it over Wi-Fi. It can be done like that as well. So, or only upload on Wi-Fi, and in that case, there's zero footprint.
Cool. I don't want to monopolize all the questions. I got more, but Tracy, I know I see you itching there.
Yeah, it was a great presentation. Thank you so much. And it was, I've been watching and looking at ODIN for a long time, so I keep noodling around with projects when we can use them. But I am really curious how sitting with participants is like when, we obviously are working with people with opioid use disorders, or maybe not necessarily even diagnosable disorders, but that are regularly using opioids and don't want to be tracked and otherwise, but clearly have a lot to share and tell us, and are at great risk. So, but how does that conversation look like to encourage trust and with this software?
Yeah, I mean, I think, for example, the paper that I cited talks a little bit about that with the rural cohort, with the COBRE cohort up here in Nebraska. I think that it's a delicate conversation, and it's important to make clear how much agency they have. Like, they cannot answer a question, they can turn off the GPS functionality of the app at any time. They have to see that, this is the coupon number that you're typing in. Everything that we have is just going to have this coupon number on it. They have to see the certificate of confidentiality and understand what that means. And, these things taken together, I think they end up helping. And then, of course, if your recruitment has gone through RDS, then you're using some of the referral, the power of trusted referral by a trusted party in recruitment as well. So I was worried about it, but surprisingly, it hasn't been an issue with homeless youth. It hasn't really been an issue with the people in the treatment facility, alcohol treatment facility. We've been able to recruit there, and then in the radar cohort as well. But it does take planning to head off all of those concerns.
That's great. That's really helpful. I was also thinking about some of the structure, the architecture around thinking about some of the rules, and thinking really about important times and places to structure your the when data collection is, when pinging is going to occur. Is it necessary to have a ton of information kind of going into it, or is the tool something also that could be exploratory? Could things go off kind of randomly within waking hours or things like this that would help develop patterns?
That's really interesting. We haven't done that. But again, I would say that in terms of the expandability of this system, I see it in 3 axes: sensors and rules and types of questions, right? And I've really tried to make it so that I don't pretend to know what kinds of sensors would be supported. Like Jody mentioned, maybe, Alexa is a kind of sensor that needs to be incorporated tomorrow, or somebody comes up with a new kind of sensor in the iWatch, in the Apple Watch. So sensors, and then every time you introduce a new sensor, you have a whole new suite of rules that come with it. We haven't had a rule that says, of the type, ask this question at a random point in time within this interval, right? Because until now, we've really only had people say, I want it to be like clockwork at this time. Yeah. But it's a pretty straightforward rule to throw into the mix. Yeah, we could do that. And it's a great idea. The system does let you add new questions and rules to a study as it's going on. And it lets you say, okay, these 5 people, I'm going to move them into group 2 now. And group 2 has these rules associated with it. Like, while on day 20 of the study, you can just shift over half your cohort to a new set of rules. The analytics piece of that is daunting, but it can be done. At least the technology is there to do it. Yeah. So what I'm trying to say is, if the use case that you have in mind for this requires a different kind of rule, or a different kind of sensor, or a different kind of question, it can be easily incorporated. Between the time that a grant proposal is written and the start date of a grant is like a whole slew of time, and we'd be happy to make it so that you weren't stressed out writing writing the grant as though the feature exists and assuring you that by the time that rolls out, the feature will exist. So
That's exciting.
Dr.
Expect the call.
Dr. Jacka, you had a question?
Yeah, thank you so much. Really enjoyed this presentation and really interested in the technology. I have kind of two questions, one of which you kind of just answered then. The first is, so the very complex data set is not something I have expertise in. Is there capacity within the group to help with the analysis, whether that's kind of like funded from our end or from your end? Does that make sense?
yeah, I do. The analysis is the analytic techniques are an area of active research. That's what I would put. That's how I would put it. But usually, what happens is when we design one of these projects that's going to use ODIN, we have to think through that analytics. What's the analytic strategy in the research strategy methods section? What are you going to do with this data to test the hypotheses for that you're planning to use? And so we do have a sort of arsenal of things that we have used in the past that seem to be effective ways of dealing with this longitudinal modeling problem.
Fantastic, super, and thanks so much. And the other question was, I'm sorry if I missed it, was the Bluetooth proximity technology. Does it say, can it tell if it's the same individual that you're recontacting with? Is there kind of like a device ID, or is it just the presence of another device?
So what happens is when you register, you type in a coupon, right? Mm-hmm. And then what happens is that every 5 minutes on the dot, your phone will change its Bluetooth name to a different name that is an encrypted form of your coupon, right, and run a scan. And so at that time, it will see a bunch of other Bluetooth devices nearby, and it'll be able to say, oh, there's like 3 other people in the study nearby. And it will reverse encrypt the name and figure out that it's coupon so-and-so and coupon so-and-so that I'm nearby. And so you will be able to detect repeat co-location and social dynamics between these individuals that are identified only by their coupon ID. So you can deduce a social network out of this.
And it doesn't capture any other information about like non-study folks that are nearby in terms of like, no.
It doesn't currently, just because it's not clear what to do with it. But if you say, I have a use case for that, right? Then we can make it happen. I just, like knowing that you're near your Bluetooth printer and your phone and all this stuff is just not clear what to do with it.
Okay.
But yeah. It does see all that stuff. It just doesn't write it down. It doesn't make a note of the things that it sees that are not in the study.
Great. Thanks very much.
Well, I think, one thing that would be useful in that context is if we could figure out some kind of biometric way of knowing when people are using. You also want to identify people that are using alone, because that's a high risk for fatal overdose.
Right.
That might be useful just to know.
Yeah, I mean, I feel like that you might find that there's some gap in the there might be a sensor development project here as well, potentially. It may be that you need some data, that we conceptualize a study that needs a very specific kind of sensor, and then we could go and try and find people to build the sensor to incorporate into the platform.
Sure. Or just an algorithm using whatever data can be found.
Right.
Weighing them differently. You mentioned this term coupon, which I think is the payment. And it seems to me like, there's this stuff that these, addiction to gaming, to gambling, online gambling is it's kind of I think is newly classified as a addiction by the savants, but it clearly is an addiction. And I remember hearing the story a few years ago about how well, first of all, online gambling is taking off. And a lot of the online gamblers, they make these websites that are just have all the right noises and bings and lights and make you, they recreate being in a casino and the excitement of the glamour and the glitz. And it fires off those receptors so that people feel like, and they pull you in by giving you, you get a free $100 to gamble with.
Right.
It doesn't mean anything, or, it's play money, but you get a certain number of things to play with. And you can buy, another $100 play money for 50 cents. And so you just, you lose that 100, but you're getting what people get from the gambling. And so they pay that 50 cents again and again, and it just sucks you in. And so people spend hours and hours, and and it fires up those same receptors, and it's a classic addiction. But I'm kind of thinking about that, and how do you, obviously we want people to answer the questions when you ask them, and you want them to answer them as accurately as possible. So you can kind of figure out where's the sweet spot where you're actually getting people to kind of look forward to, I want to have a question, and then they see like, oh yeah, let me prioritize this. You hold on a minute, I'm not going to change your diapers now. I'm going to I'm going to answer this because I get a coupon.
Yeah. I mean, I actually in the R21 on alcohol, we are changing. I didn't talk about it, but we are looking at different modalities of incentivizing. So, in 1 week, we say every question that you answer, you get 5 cents. In another week, we say, if you answer more than 80% of the questions this week, you'll get $20. And there are different ways of structuring the behavioral economics of it. And seeing what the optimal strategy might be on that, so that at least we can justify it when we go on R01 scale to try and collect the data. But you're right, it is really, the more it can be gamified, the better it would be. The one puzzle that we haven't solved with that is that I didn't show you, but it is possible to say that I want buttons associated with these questions, so that a person can press a button on the screen and answer this question. And that, of course, is very, you can't really attach an incentive to that, because then the person just sits there and presses the button all day long and answers, the question that they've self-triggered. So, but yeah.
Great. Well, this is so fantastic, and we look forward to talking more again with and exploring the ODIN software website. And clearly, you've piqued a lot of people's interest, and I think look forward to collaborations in the future on some fun research. Thank you so much.
Super. Thank you.
Yes.
Thank you very much for the invitation, and thank you for attending.